Hi, future doctors. Welcome to the next class. We were discussing cells connected in parallel. Now we will see if n identical cells, n identical cells connected in parallel, n identical cells connected in parallel to an external resistance. So all these connected to parallel. Small r internal resistance, EMF, each EMF is going to be. So now all these connected to an external resistance capital R. Now, what is the total current passing through this? For this, we have to make it simple circuit. So all these n identical cells, if n identical cells or two identical cells or three identical cells connected in parallel, what is the effective EMF means E. Now, what is the effective internal resistance? Here, n cells are there, therefore, R by N. Now, it is connected to an external resistance capital R. Now, this circuit we made like this. Now, how much current is passing through this? So, I is equal to, general equation we can write E by R plus R by N. So, if you are taking LCM small n, NR plus small r by N. That is nothing but NE by NR plus R. So this is the equation for current passing through this external resistor. Next, what is the condition? What is the condition to get maximum current? So already we discussed that condition to get maximum current, denominator should be minimum. Therefore, whenever current is going to become maximum, so NE by, this denominator should be minimum means N capital R is equal to small r. So this one we will write NR plus NR. Otherwise, this one we will write small r plus small r. Now what you will get? NE by NR plus NR 2NR or NE by 2R. Now if you cancel N and N, so what is the equation for maximum current? E by 2 capital R, otherwise NE by 2 small r. So this is about how we are going to get maximum current, and condition for maximum current. Here N is equal to small r by capital R. Already in series also we discussed. And maximum power also they will ask. Once you came to know the current, you will get all those. So condition for maximum current. I hope you people understood this. Next time. So within this, they may ask problems like this. The cell of internal resistance R1, EMF E1 is connected to two another cells, EMF E2, R2. Let us assume this is B, E3, R. This is A. Now, what is the effective EMF between A and B? What is the effective internal resistance between A and B? So, for this, how we will do means, here these two connected in parallel. Positive is positive connected. These two connected parallel means, so this green color combination, this is left one, E1, R1. Now, what is the effective EMF here means? So, E23. This is R23. So E23, so equivalent EMF, E2R3 plus E3R2 by R2 plus R3. And what is R23? R23 is nothing but R2 R3 by R2 plus R3. So equivalent EMF formula we wrote E1 R2 plus E2 R1 by R1 plus R2. Same like this is E23 R2. Now again E1 and E23. See here negative is connected with positive. Therefore, whenever negative is connected with positive, what is the equivalent EMF? These two connected in series. Therefore, E1 plus E23. And what is RAB? R equivalent. R1 plus R23. Now, final answer. EAB is equal to E1 plus what is E23? E2 R3 plus E3 R2 by R2 plus R2. RAB. R1 plus R2 R3 by R2 plus R2. So if you got here, let us assume negative, then here you will write minus. Here this is plus 1, isn't it? So like this also they will be asking. At that time you should be very careful while solving problem. Here positive positive connected, therefore we wrote here plus. If positive negative is connected, you have to write here minus. Okay. So try to do problems like this. Definitely you can do very well in your exam. Thank you.